In this video, we are going to talk about all of 2.1, which is basically frequency tables and histograms. And these are probably things that you're familiar with. You might not remember all the details from another math class, but typically this is one of the topics that you just kind of do repeatedly throughout elementary school and junior high. So you've probably at least seen these, but today we're going to fine tune all of that stuff that you might already know. All right, so the first section, 2.1a, is all about frequency tables. And so this is talking about how we're going to organize our data so that we can see what's going on. So the frequency is the number of times a value of the data occurs. And a frequency table is constructed by arranging the data from least to greatest with their corresponding frequencies. And so we do not need to rewrite these numbers from least to greatest. They'll just kind of naturally form as we do the tallies. And so I'm just going to so this one doesn't say anything in example 1 about how to construct a frequency table. It just says to do it. And so I'm just going to explain my thought process as I create this and show you different ways that that could be done on future problems. And so I'm just going to glance at the data. And I see 2 is the smallest number. And then looking through here, it looks like 18 is the biggest number. And so I think I'm going to create a frequency table counting by 5s or a bin width of 5. So I want to start either with the lowest number or below the lowest number. So I'm going to start with 1. And then I'm going to go 1, 2, 3, 4, 5 will give me a bin width of 5. The reason I count on my fingers, it kind of sounds silly since I was counting on out loud and on my fingers the same way, but a lot of people get the bin width mixed up. So next I'm going to go 6 because I start at the next number, 6, 7, 8, 9, 10. I'm going to end at 10. So I still have that bin width of 5. And so all of these, the word I'm saying, it might be hard to understand. Bin width is going to be 5 in this example. And so I start at the next number, 11 to 15, and I want to go past my highest number. So I have 18. So the last one is going to be 16 to 20, and then I can stop there. Bin width is hard because, no, it's not hard. It's hard to remember is what I'm trying to say, because your eyes just want to do subtraction, right? Like you see the 1 and the dash and the 5, this right here, and your eyes just kind of flip it around and you're doing 5 minus 1 is 4 in your brain. But that is not what we're talking about here. And so I like to count it on my fingers just to make sure I'm getting all the way up to the bin width of 5, just the first time. Once you get the pattern, then you don't need to count on your fingers anymore. But if you notice the pattern here, I have 5, I am adding 5 here. So I did 1 to 5, I counted that out. I did the next number, 6, and then I added 5. 5 plus 10 is 5 plus 5 is 10. Go to the next number, 11, 10 plus 5 is 15, and so forth. And so you can have that pattern for sure if you don't want to count on your fingers the whole time, but definitely I like to count on my fingers the first time to make sure I have that correct bin width. Again, a lot of people think that is 4. Okay, so I have these bins. Oops, well, it's just going to be red. I forgot to change the color. And then I'm going to have the tallies. Oops, hang on a second, it's too close. I have the tallies and then the actual frequency number here. So this first column is going to be the tally, T-A-L-L-Y, and then the last column is going to be the actual frequency. And so I just go through this list of numbers and I make tallies. We talked about this, I think, in the last video, where it's like 1, 2, 3, 4, 5, 6, like that. That's what a tally is. So we're going to do that as we go through here. So the first number I have is 2. So I'm going to tally it, cross it off so I don't forget, or so I don't reuse it. Next number I have is 5. 5 is between 1 and 5, so it's going to go right there in the first row. Next I have a 7. The 7 is between 6 and 10, so I put it in the second row. And so I have a 3 and a 2, and then a 10 is going to come down here in the second row. The 18 is going to go all the way to the bottom. 5 is going to go in the first row, so I put the slash diagonally to count for 5. It just makes it easier to count when we get to the final column. So I did the 5. I have 2 10s. I have a 5 and a 7. 5 goes there, 7 goes there. 13 and 12 both go in the third row. And then a 2 and a 5 both go in the top. So I'm just tallying them up. I'm seeing how many of each number I have, or each number that goes in the bin. So from 1 through 5, I have 8 of them because there's 5, 6, 7, 8. For 6 through 10, I have 5 of them. 11 through 15 is 2, and then 16 to 20 is 1. So one thing that is important is that your bin width is the same for all of them. So they all have a bin width of 5. You start below the lowest number or at the lowest number. I could have started at 2, but I chose to start at 1. I suppose I could have started at 0 because there could be zeros in a problem. If you don't commute to work at all, if you work from home, there'd be a 0. And then the biggest number, you just keep following the pattern, adding the bin width until you get to your last number, which is greater than or equal to the biggest number in your data set. Finally, you just do all the tallies and you write the numbers out as their frequency. The tallies is for your information. On the test or on the homework, you're not going to be writing in the tallies. It's just an easy way to keep track of it. This last column over here is the actual answer. That's the important column. Oops, sorry. But the tallies help us get there. Okay, so let's try this again. We'll use a different bin width. And so I'm looking at the numbers. It looks like, again, 2 is the smallest number, and then 9 is the biggest number. And for this one, I'm going to do a bin width of 2. There's no real rhyme or reason to this. You won't have to make that choice. The problem will tell you what to do for the bin width. I'm just trying to show you some different bin widths to see what's going on. So this time I'm going to start with my lowest number. I'm going to start with 2, again, just because I can. So a bin width of 2, I have 2, 3. So I have to end at 3. Counting it out, 2, 3, that's 2 numbers. So then I add 1, which gives me to 4. I'm adding 1 when I go this way, and then I add the bin width when I go this way. So then this number has to be 5. And then once you do this a couple times, you get the pattern. 6 and 7, 8 and 9. And I'm going to stop there at 9 because that's my biggest number. I don't need to go any farther. If I did go farther, I would just end up with a bunch of rows that had zeros in them, which is not helpful. Okay, so we have all of these numbers here. I'm going to make my tallies and then write my final answers. So tally and then frequency. So it goes 3, 4, 4, 8, 7, 2, 3, 8, 3, 9, 9. So in this example, none of the numbers have, sorry, my face is really close. I'm trying to hold my computer screen and so it doesn't fall over. Anyways, what was I saying? None of these have numbers over 5. So who cares? There's not that many numbers in this list. That's fine. We get what we get. And in this example, we have some small numbers. Okay, that's perfect. And so this way our data is more organized. And so now it's easier to see that we have the average number of emergency doctor visits per day in a small city. And so 4 of the days have 2 to 3 visits, and 4 of the days have 8 to 9 visits. So we can see there's a spike on both ends, but only one day had 6 to 7 visits. And so it just gives us the data in a more organized fashion, so that way we can use it to make conclusions later on. Right now, we're just playing with the data. Okay, this example right here, it just sets it up for us. It already has the bins. You can see the patterns that they all start with 0 and they all end in 9. So the bin width is the same throughout, which is necessary. There isn't a column for tallying, so we can just kind of tally up as we go. And at any point you're like really getting the hang of this, just fast forward, pause it, do it yourself, and then fast forward to the end just to make sure you have the right answer. I don't mean the end of the video. You're going to obviously miss all my historical jokes if you do that. Just fast forward to the end of this problem. All right, but before we start this problem, let's talk about the bin width. So take a second, think about from 0 to 9 what you think the bin width is, and then think about why, if you said 9, well, you're wrong, right? Let's count it out. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The bin width is 10 in this problem. If you got it wrong, don't worry about it. Just count on your fingers. You're out here in video land. No one can even see you counting on your fingers. It's no big deal. And in my in-person classes, I literally have people counting on their fingers in the test, including me. So don't even worry about it. All right, so now we're going to see the ages at a swim class and see what's going on here. So we have a 10 and, oh, let me just pause for a second before I do this. If I was to glance through here, oops, I'm trying to erase this like it's a real pen. Here, let me hit my button. If I was to glance through this before we start, it looks like these are in number order, so that'll be very helpful. So 10 is the smallest and 59 is the biggest, which means there's going to be nothing happening here in 0 to 9. You can just very easily see that there's no one-digit numbers in this list. So if I was to create my own table, I would not have included that list, or that bin. However, it's included, so what are we going to do? Okay, so we have 10. So this is, since it's in number order, all of these are going to go in the first one. So I have 10, 11, 16. So 1, 2, 3, 4, 5, 6. 6 frequency here. It's a lot easier when they're in number order, but it's a little time consuming to do it yourself. So if you're finding a jumbled list like we have above, I think it's just as easy to do the tallies. All right, 20 to 29 is going to be these people right here. 1, 2, 3, 4, 5, 6. Now, there's nobody from 30 to 39, but that's important to have that 0 in the middle because it shows that gap in ages. Something's going on in there at this recreation center. For some reason, nobody 30 to 39 is signing up. So perhaps if you were in charge of marketing, maybe you would start targeting that age group. I just have the 1 49-year-old, and then there's 2 people in their 50s. So we have 0 to 9-year-olds. We have 6 10 to 19-year-olds, 6 20 to 29-year-olds, 1 40 to 49-year-old, and 2 50 to 59-year-olds. And again, if this was your job, you would do something with the data. I don't know. It's not my job. But that's just how you organize it. Okay. So enough with frequency tables. Now let's talk about different types. So this first one is going to be for relative frequencies. And so a relative frequency is the percentage or fraction of the frequency that each bin represents. So you'll notice they already have the bins. In this example, they have a bin width of 5. 0, 1, 2, 3, 4 is 5 numbers. And the frequency is already done for us, so we don't need to tally anything. In fact, they didn't even give us any data, so there's nothing to tally. However, we were asked to find the relative frequency. And so what we want to do is what part out of the whole is each line or each bin. Now, typically, you would have to add all these numbers up, throw them in your calculator or whatever to add all those numbers up. However, in this particular problem, it tells us already that there's 70 college students being interviewed for this problem. So we already know that there's 70 total. And so for the relative frequency, it says round to the nearest hundredth, which tells me that we need a decimal to the nearest hundredth. So I'm not going to worry about any fractions that aren't reduced. It doesn't matter if they're reduced or not because we're rounding to the nearest hundredth for our final answer. And so for the relative frequency, it's just going to be a lot of fractions over 70. The 0 to 4 row is 2 people out of the total of 70. The 5 to 9 row is 7 people out of the total of 70. So this number goes on top, and then 70 goes on the bottom every time. So we have 11 out of 70, 17 out of 70, 18 out of 70, 12 out of 70, and 3 out of 70. Now, what we're going to do next is we are going to find the fraction to the nearest hundredth. So I'm just going to switch my video real quick to my, I'm going to pause it real quick, and I'm going to, when I come back, you will be able to see my calculator. Okay, so hopefully you didn't notice too much lag there, but I had to get my calculator set up in order to do this problem and get you that, get it projected nice and clearly as much as possible. Okay, so what we're doing is 2 out of 70 first. So I am going to switch over to my calculator video, and we're going to do 2 out of 70, and we're going to round to the nearest tenth. Now, when you type it in, however you type in 2 out of 70, 2 divided by 70, if you're using a cell phone at this point as your only calculator, that is fine too, because at this first video in chapter 2, it doesn't really matter. We're not getting too complicated, but you will need a better calculator than a cell phone by the end of chapter 2. All right, the reason I wanted to do this here is just to talk about rounding. So this one said to round to the nearest tenth. So I have 0.028, blah, 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 blah. The nearest tenth is the 2. The 2 is in, no, it said the hundredth. It said to round to the nearest hundredth. So the hundredth is the 2. I notice next to the 2 is an 8. So I'm going to round up and put 0.03 for this example right here. So let me go back to the screen, and I'm going to put 0.03 in here for my answer. 7 out of 70, you can type that into your calculator as well. I'm going to type mine. I don't need to show you this one though, because this one turns out pretty small, or not small, pretty easy because there's no rounding needed. It just gives you 0.01. And I'm going to do one more on my calculator, the 11 out of 70. And so I'm going to type 11 divided by 70 into the calculator. And I get this. So the thing, what's happening here is when you divide by 7, it almost always will give you this never-ending repeating decimal. It's just when 7 divided by 70, because the 7's cancel, it would turn out nicely. But most of these are going to be terrible in terms of rounding, which is I did on purpose so we could practice rounding. But again, the 5 is in the hundredths place, and the 7 is saying to round up. So this is going to be 0.16 on our table. I just wanted to take a few minutes to practice rounding, because I just get all kinds of issues when it comes to the test that people either don't know how to round or they forget which place they're rounding to. So again, we're doing the nearest hundredth. Don't lose points on a test because you rounded to the wrong spot. If on any of these problems, you're not getting the same answer as me, shoot me an email, let me know, and we can talk about rounding. All right, I'm not going to keep jumping back and forth to my calculator. I lied. I am going to jump one more time. And the reason is the rounding on this one I want to talk about. And so I typed in 17 divided by 70. The nearest hundredths would be the 4. And this time, the number next to the 4 is lower than, lower than 5. And so the 2 is telling the 4 to stay the same. So this is just going to be 0.24. Okay, that's the last calculator I'm going to show you, at least for right now. So that way we can kind of speed through the rest of these problems. Oh, now I'm disappeared completely. Here I am. Okay, 0.24. So then we have 18 divided by 70. I'm getting rounded to the hundredth is 0.26. And then I have 12 divided by 70. which is 0.17. And finally, 3 divided by 70, which is 0.04. Now, when I add up all these relative frequencies, it should equal 1 whole, because all together they represent 70 out of the 70 total 1 whole. But since we were rounding, there is the possibility that we're going to get anywhere from like 0.98 to maybe like 1.02. So it might not quite equal 1 whenever we're rounding. Sometimes we're rounding and it kind of balances out and it does equal 1. Other times it's very close to 1. But in general, what am I pointing at over here? The total relative frequency should equal 1. Okay. Another layer to relative frequency, we now have the cumulative relative frequency. And so cumulative is a word that we use in statistics a lot. Other than statistics, you might have heard about it like in your GPA. You have your GPA and then you have your cumulative GPA. So you have, messing with the light over here. Okay, you have one semester's GPA or you have all the semester's GPA. And so cumulative is going to be all of the relative frequencies where we are and everything before it. So the first row, we only have one number, 0.04. So that's it. That's the cumulative relative frequency. But in row 2, we have our row 2 number plus everything before it. So we get 26 plus 4 is 30. We get 0.3. And anytime I do decimals in my head, you're welcome to use a calculator to figure it out as well. Okay. So every time I take the number that I'm on and the row before it. So now I'm going to take the number that I'm on, 0.54, and the row before it, 0.3, and I get 0.84. So I'm just taking, so 0.84, I like to just take the row I'm on and add what's before it because this is already smushed together. Another way you could do it is just add all of these numbers. It's the same thing because these two, that's our 0.3, and then we add our 0.54. So it's the same thing. It's just shorter to write if you write the row before it. Okay, so finally, I'm going to have 0.16 plus the row before it, 0.84. And again, since it's the total of everything, it should equal 1, just like I mentioned above. So here we had a problem where it asked for it gave us the frequency, it gave us the relative frequency, and it asked for the cumulative relative frequency. So we just took whatever row we were on and added the row before it. So question A, complete the frequencies, the cumulative relative frequency. So basically complete the table, which we just did. For question B, it says what percentage of children sleep more than 8 hours a night? And so for this, more than 8 hours is going to be these two. Now, there's one thing that some of the algebra people out there, the people that love algebra, will have to get used to in this class, and that's going to be inequalities. Technically, more than 8 hours doesn't include 8, but in statistics, we blur the line between more than versus greater than or equal to. We just kind of say it's close enough. Because here there's no distinction between the 8 hours versus the 9 hours versus the 10 versus the 11. The 8 through 11 is all grouped together. So I guess what I'm saying is when in doubt, just go for the less picky answer. In this case, we're going to just include the 8 through 11, all of them, because there's no way to know the difference. So what percentage of children sleep more than 8 hours of each night? Well, we know 8 to 11 is 0.54. And we know 12 to 15 is 0.16. It's just those two columns. So I can't use the cumulative relative frequency because it's not everything since the beginning. Cumulative would include everything since the beginning. Here we're just those two rows only. So that's going to be let's see, that's a 0, carry the 1, 5, 6. That's going to be 0.7. And since it said what percentage, I'm going to convert this 0.7 into a percentage, which is 70%. Percentages, we just move the decimal 2 places and we throw the percent sign in. Okay, last one on this picture, we have what percentage of children sleep 7 hours or less? So we have, so this one for my algebra folk out there, 7 hours or less, it includes the 7. Again, we're not being too picky, we're just going to take both of those. 0 to 3 is 0.04. 4 to 7 is 0.26. So this is going to equal 0.3 or 30%. Few things happening in here that could shortcut us to the answer that maybe you saw or maybe you didn't see. Number 1, the or less is exactly what cumulative is talking about. It's everything from where we are and everything before. So 7 hours and everything before, well, we already did that. So we could have just gone straight to the table and taken that number because of the or less part. Another shortcut that you may have seen is that the first problem were these bottom two, the second problem were the top two, and all together it equaled our 100%. So if we already knew that this part was 70%, then that means this top part had to be 30%. So those are just a couple of shortcuts if you notice them. If you didn't notice them, just add those two numbers and get 30%. You're going to get the same answer no matter which way you do it. And when I say shortcut, it didn't really save that much time. It's just a different way of thinking through the problem. Okay. I think this is the last cumulative. Yes, and then we'll move on to histograms. So here we have research count the number of children in each household. Use this data to answer the question below. So first of all, what is the missing number? So we have a cumulative relative frequency here that's missing. And so as a reminder, we just take the number that we're on, which is 0.22. And we add the number above it, which is 0.31. And we get 0.53 as our final answer for A. And you could double check this. You could take 0.25 and add 0.53 to equal 78. Just to double check. So 0.53 is the right number. Okay. 0.53. What percentage of families have 3 or more children? So anytime it says or more, we cannot use the cumulative numbers. We just have to add them up. So here's 3 or more. So we're just going to have to add up those 3 numbers. And you're welcome to do this in your head or pull out your calculator. Just type all those in, sometimes with decimals, especially because like the 0.09 right there, sometimes people mix them up. So it's just, just pull out your calculator, no worries. So this is 0.47 when I add them all up. However, it's asking for the percentage of families. So I'm going to change that into a percent, which is 47%. All right, finally, what percentage of families have 1 or 2 children? Now, when we're doing this problem, 1 or 2 are just those 2 numbers right there, not the top. So again, I can't use the cumulative relative frequency here. However, 1 child, 0.11, 2 children, 0.22, add these together. That's not terrible addition right there, just 0.33. Sorry if my decimals are dropping. Make them a little darker. Okay, so then that is 33%. All right, there we go. We have talked about frequency tables. And because the next section is so short, I don't want to make another video. So I'm just going to jump in here and just finish up this, this whole 2.1. But again, I said this a bunch in the last couple of videos. Whenever you see this red headline, that means it's a separate homework assignment just to keep The less topics I put per homework assignment, the faster you get to 100%. So that's why sometimes I separate them. Okay, last but not least, histograms. I know you've drawn not box plots. What are these called? These are histograms, but they're also called box graphs, bar graphs. There we go. I know you've drawn bar graphs before. I don't use them. That's why I forgot what they're called. We are going to do histograms, which look like bar graphs because they have those rectangles, but they touch. So that is one thing about histograms is they need to touch. They're joining boxes. And this will help us talk about the center and spread of data. These are two topics that are huge in this class, center and spread. However, just not at this moment. We're going to get into that in section 2.6. All right, so one advantage of a histogram is it makes it easier to see what's going on because you have a picture. And we talked about in another video about the scale affecting, pictures can be misleading. So we want to make sure we have a nice little scale. But what we have over here is the frequency. So this side, the y-axis is always the frequency, and then the x-axis is always the units of what we're talking about. Now, I said it's always the frequency. It could be the relative frequency. We'll talk about both of those, but that's always going to go on the left-hand side on the y-axis. So we're going to start at 0 and go up to whatever our highest frequency is. But we're not going to go up to like too high. 100% is as high as you can get for frequency. So it won't be too bad. Okay, so here's one that's already done for us. And I want to point out something with the axes here. Sometimes if I drew a histogram like this, and I said 0, 1, 2, 3. Sometimes it can get confusing on where 1 goes. People are like, wait, is 1 over here or is 1 over here? And so a way to avoid that confusion is to have what you see here. We have a 0.5 and a 1.5. Nobody's reading a half a book, but that is very clear that 1 is in the middle here. So these are all the 1s. And that 2 is in the middle here, and 3 and 4 and 5 and 6. So this right here, this box represents all of the people that read one book. All right, then how to read this? Well, we have a height of this rectangle. First of all of them are the same width. They're all 1 apart. From 0.5 to 1.5 is 1. From 1.5 to 2.5 is 1. From 2.5 to 3.5 is 1. That goes back to the beginning of this video when I said you need to have the same bin width. So the width of all these rectangles is 1. So let's just make some notes on what histograms need to have. So the width of the rectangles or the bars is all the same. That goes back to our frequency table where the bin width needs to be the same. Another thing about frequency or about histograms, oh my gosh, this is supposed to say, what am I trying to say? Rectangles. That's supposed to be a C. There we go. Rectangles are touching. So again, it said that up on the previous page, but I just want to make sure that we have that. So those are two very important things about histograms, which are pictures of frequency tables. So let's just talk about what's going on in this histogram first, and then we'll draw one. So given this histogram, how many students read greater than 4.5, but less than 5.5 books? So in other words, how many people read 5 books each month? So we have 4.5 to 5.5. How many people read that many books? So since the bin width, we don't worry about the bin width because it's all the same, and so it doesn't get calculated into this problem. What we want is the height. The height is going to tell us the frequency. So here, this black line you can see is drawn between these two gray lines. The gray line, the bottom one is 4, and the top one is 6. So in between, there's a 5. 5 people read between 4.5 and 5.5 books. You know what? There's something I like to do at the beginning of every problem, and I totally forgot to do it. What I like to do at the beginning of every histogram problem is just find all the heights right away, so then I don't have to keep looking at the heights every time. Okay, so let's look at this first rectangle. It goes up to right here, which is in between 10 and 12, so that's 11. The second rectangle is right on the line, so we have 10. This is the number of people, so this isn't going to be a decimal. So if it looks like halfway between something, then it's the whole number in between there. It's not, don't worry about like, oh, is that 11.25? No, we're not talking about 0.25 people. All right, this next rectangle goes all the way up to the top, which is 16. And then 6. We already said that was 5. And finally, this last one is on that line, so it's a 2. I'm going to erase the black numbers here just so we don't get them mixed up with something else. Okay, so how many people read 5 books? That would be those 5 people right there. How many students checked out more than 2.5 books? Okay, so that's 3 books, 4 books, 5 books. I'm going to go from 2.5. I want all of these rectangles right here. So I have a 16, a 6, a 5, and a 2, because I'm looking at the heights of all 4 of these rectangles right here. And I'm going to throw that into my calculator. 16 plus 6 plus 5 plus 2, and I get 29 students. Forgot that on the top one. 5 students. The reason I like to have that is because we're talking about 5 books. And in this case, 5 students read 5 books. So we're not getting confused as to what the 5 is for. 5 is for both students and books. All right, last but not, oh no. Oh gosh, we have a couple more. Okay, part C. How many students checked out at least 4.5 books? Okay, 4.5 at least. Okay, this one gets people a lot. At least 4.5 books. And so the best example, depending on which one is more relevant to you, you have to be at least 16 to get your driver's license. You have to be at least 18 to vote. You have to be at least 21 to go to a bar or to buy alcohol. So at least means that number or bigger, right? At least 16 to drive. Well, you could drive at 17, you can drive at 18, but you can't drive at 2. You can't go less. So at least means that number or more. Same thing with voting. You can't vote at 3 years old, but you could vote at 18, you can vote at 19, you can vote at 20, and so forth. So at least this phrase will come up throughout this whole class, this course, and it gets people every time. So I like to talk about it as much as possible. 4.5 or more. So we have 5 people in this first one and 2 people in the second one. So that would be 7 students. If we were going the other direction, it would say at most. Oh no, what did I do? I just erased a lot of stuff. Okay, whatever. It's fine. Oh gosh, everything's getting erased. Okay, well, just one more and then we'll be done. How many students checked out 3.5 or less? This is the cumulative relative frequency. However, it wasn't given, so it doesn't really help us to know that, but we start at 3.5 and go smaller. So we need those 3 columns. We have, oops, trying to scoot it up, 11, 10, and 16. 11, 10, and 16, 10, 20, 30, 7 students read or checked out 3.5 books or less. All right, now we are going to make our own. Just plug my mouse back in, sorry, it's a weird noise. But we have students in a statistics class record how many movies they have watched in the previous month. The data is listed below. Here we have our data. Now this is in number order, but I still like to draw a frequency table before I do this. So I have my bin, just because it's easier if I already have the tallies done to draw the histogram and not forget something. And so I'm just going to do a bin width of 1 because it only goes from 0 to 6. There's not much happening here. 1, 2, 3, 4, 5, 6, and we can talk about what happens. Oh, none of these bins will have 0, so I guess we can't talk about that. But I have 3 1s. I have 1, 2, 3, 4, 5, 6, 7, 8 2s, 3 3s, 2 4s, a 5, and a 6. We're going to do this twice just to see what different histograms look like. Okay. And so to be like the one above, I can just, well, first of all, the greatest frequency here is 8. 3, 4, 5, 6, 7, 8. I'll just put a number at 5 and then the top at 8. And then we can go like before we did above, we could say 0.5, 1.5, 2. That way we know exactly where everything goes. 3.5, 4.5, 5.5, and 6.5. So 1 is going to be a height of 3. Remember all the rectangles, oopsies, that's a terrible rectangle. All the rectangles have the same width and all the rectangles are touching. So this one had a height of 3. The next one had a height of 8. So to make them touching, I'll just continue on this, even though it's kind of a jaggedy looking line, I can still continue on up to 8. The next one had a height of 3. Again, we have a 3, so we have that same height right there, 3. Then we go down to 2. And then the bottom two both have 1. And there we have our histogram. We'll talk about what that shape means in a different video. But I wanted to try the same thing again with a bin width of 2. I have to write a little smaller. I'm doing a different color so it doesn't overlap. But a bin width of 2 would be bin frequency. And maybe we should match our decimals up here. So I go 0.5 to 2.5. And then 2.6 to 4.5. I'm adding 2 for that bin width of 2. 4.6 to, it doesn't matter actually, I'm going to use 0.5 because there's nothing that's going to be duplicated. There's no decimals in this problem. So if I have a decimal here, we're not going to get confused. Okay. So when I say we're not going to get confused, if the number 4.5 appeared, I would say like, oh no, which bin does it go in? But the number 4.5 won't appear, so it's not going to mess us up on this. Okay, 0.5 to 2.5. I'm doing this whole thing in red just so I can write over the same problem. That's all of these guys. There was 3 1s and there was 8 2s, so there's 11 numbers there. 2.5 to 4.5, so I'd be from 3 and 4. There was 3 3s and 2 4s, so there's 5 numbers there. And last but not least, there's 2 numbers in the last one. So I still have all the numbers. This chart is now going to go up to 11, so it's going to be a little higher than before. But the bins are going to be wider. So I don't need to write 1.5. Oops. The eraser button is like right where I hold my pen, so it's kind of awkward. So the bins are wider, and I don't need to write those numbers in between because they're not relevant to this problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my first rectangle in red compared to the blue is going to be taller, and it's going to be fatter because it has a bigger bin, and the bigger bin captured more numbers. My next one, 2.5 to 4.5, is a height of 5. And the last one, 4.5 to 6.5, has a height of 2. And so as best you can, they should all have the same width. They're pretty close, considering I do this by hand. They're pretty close to the same width, but numerically they actually are the same width. But you'll notice the shape is a little different here. Let's see, I'll get purple. The shape on this first one, it starts low and then it goes high and then it goes down. The second one just starts high and then it goes down. So there's a little different shape that happens with the different bins. So depending on the problem, you might need to have a certain bin width to make more sense within that problem. In this example, we were talking about how many movies people watched in a month. So we might want to be more specific and do 1 movie compared to 2 movies and show that difference. But That's just the shape and how to pick that. That's a topic for another video. I think we've covered enough in this video. Um, so 2.1a frequency tables is a separate homework problem from 2.1b, which is histograms. So those are two different homework assignments. And I think that's all I have to say. So email me in Canvas if you have any questions. Otherwise, I will see you in the next video. Bye.